So my name is William Cockrell. I currently work for Edwards Life Sciences. I'm a director of business solutions and digital engineering solutions. I joined Edwards in 2022. Previous to that, I worked for Raytheon for 20 years. 17 of those was with Raytheon Missile Systems in Tucson, Arizona. And before I worked for Raytheon, I worked for Siemens Transportation, designing light rail vehicles. I'm a member of ASME, and I've been a member of ASME since 2013, specifically participating in the ASME Y14 committees. I'm now, having been on the board or involved with Y14 for so many years, I'm a voting member on the main committee, the Y14 main committee. I'm the chair of Y1447, which is model-based definition schema. I'm a vice chair for 41, which is also digital product definition data, which is commonly tied to MBD. I'm also vice chair for 1437, which is composites, and I'm a member of 14.8 and 1446. And I've gotten a lot out of it, and it really has helped as I've worked for the various companies to be able to understand what's coming in the standards and get those implemented in our company as fast as the standard can come out. So, when we look at why we want or what we've used DFX for, actually, this is not my slide. So I apologize for that. So I've used DFMPro for over 10 years, and the tool does a fantastic job with manufacturability, finding issues early that will cause us downstream issues. And one of the biggest benefits that we've seen from it, besides its ability to do the various checks, and as Charlie mentioned, now they have almost 300 checks. And when I started using the tool, it was less than 200. So, they continue to add checks based on customers' input and as the need arises for the various manufacturing processes. But our early career engineers and designers got tremendous benefit from using the tool, because when you have your analysis run and you click on the issue that it's found, you can get more information. And that more information has really allowed them to understand what the issue is, because as engineering companies get busier and we have a lot of the longer term employees aging out, right, that they're leaving the companies, that means there's less opportunity for mentoring and there's less SMEs to work with those engineers. And so what I found is this tool does a great job of helping bridge that gap. And it has a thing that says push to audience. Oh, okay. I'm sorry. You're just seeing the slide. I didn't know that I had to hit the push to audience. So as I was talking, this is that slide that I was just talking to. I'm going to skip to the next slide. So the company benefits of DFMPro is it allows a standardized approach to whether you're one facility in one site or as companies in the past that I worked for, they were all over the country, all over the world. Edwards, the same thing, right? We're everywhere. And so you can set these settings up so that everyone benefits and you get a standardized approach to how engineers approach and solve manufacturability issues. And manufacturing has a huge input on this. And getting the manufacturing input makes them feel a lot better because they're part of that solution. And they know that what engineering is going to be getting guidance on is going to benefit them and speed the whole process up. And then we customize per vendors, right? So you could have one external vendor that has a certain set of methodologies and you want to check against that, and you could go and design and check your design for a different manufacturer and what common complications you may find with them and address that. So you can tailor your design based on who you're going out to, and you may be able to make a design that works for everybody, right? And then automation. I've done a lot of automation with the tool in the past and took a lot of load so that I could have it where instead of relying on engineers and designers to actually run the tool, I could automate it so that every time you checked in or you went before you went to a full release, the tool ran and you got feedback. And so then if you go to a design peer review, you understood what the complications, what the issues, what possible manufacturing challenges you were awaiting, and you could address them before you released it, which again saves time because I'm sure everyone's had the feeling of or experience of you design something, you send it out to manufacturing, whether it's internal or external, and then they give you feedback of, can you make some modification because we can save time, we can save money, whatever that case may be, and then you have to spend time trying to address it. And this tool gives you that forward-looking aspect, and you can address them early. So I'm going to show a couple, actually 4 different checks that I found to be very, very helpful with engineers. So the hole to part edge distance, okay, this could be for sheet metal. Many young engineers have their holes too close to the edge, and you'll get, breakthrough. This can go for drilling as well. They have a similar check for drilling. And this is a very common problem we have where people, young engineers out of college, see tolerances and they think they can get that hole very close, and they don't realize the ramifications, the standard 1.5 times the diameter for thickness. Deep holes, another common issue that we've seen where, if you've designed a lot, you use the 8-to-1 ratio. You might even use a 6-to-1 ratio. I've seen young engineers who want to do a 30-to-1, right? So they want to take an 1/8 inch drill bit and try to, drive it 3 or 4 inches into a part, and it's just not going to work, right? You're going to break that drill bit. So this is another one of those common things, and it's easy. The nice thing about this assistance that the tool provides is easy to understand. They give great graphics, and they walk through what's bad and what's good. So it's an easy correlation. Fillets on the top edges. This is so common, and I was guilty of it too when I was a young doing design work in the beginning. Making everything have a nice round edge on the top looks great, but if you go out and talk to somebody in manufacturing, they will tell you every time, make that a chamfer. It's much easier to inspect. It's faster to inspect. The tooling's much easier, right? You don't need a custom tool. You just cut that 45-degree edge. This was like number one for seeing a benefit for the company from a cost and manufacturing coming back and grumbling at us. And the last one is non-uniform bottom edges. So a lot of people want to make very nice designs. And, like I think of Apple, right? For some of their designs, they're really slick, but individuals would make multiple different radiuses at the bottom, and that's just much harder. You can do it, but it costs a lot more money. And having a uniform bottom edge for a pocket saves a lot of time. So, and now I think that, Charlie, do you want to jump back on? And we can look at any Q&A.
Yeah, I think Sarah's going to go ahead and push just the questions that she got from the audience.
Sure. Thank you for that informative presentation. And yeah, we'll move into the Q&A portion now. I see we have a few questions here, so let's try to get to as many as we can. Our first question, can you share specific examples where DFMPro saved time or costs in your projects?
Sure. So DFMPro's ability to identify manufacturability issues, early in the design phase allowed our engineers and designers to address the findings and then reduce the back and forth iterations with manufacturing, which could save days, could save weeks, depending on what some of those issues are.
Sarah, was there any other questions?
Yes, sorry about that. Okay, a little technical difficulty there. Our next question, what challenges were you facing before implementing DFMPro, and how did the product address them?
Let's see. Manufacturing had to work with engineers to resolve various issues on a one-on-one basis, which was very inefficient because they would work with one engineer and then they would get a similar issue maybe the next day, maybe the same day, maybe a week later. And so if you have thousands of engineers, you get this same repetitive issue, but you're only addressing it one person at a time. And that was very time consuming and really just inefficient. And so when we had DFMPro analyze designs for manufacturability, and then it provides the feedback to the engineer and the designer, that dramatically sped up the process, and we had fewer interactions with manufacturing on this back and forth. We could actually have it where engineers and designers grew their capabilities, and then when they went and spoke to manufacturing, they were actually just further enhancing their understanding of what manufacturing was looking at, what limitations there were, what kind of tools and methods that we were using in manufacturing, and so they could even design, keep furthering the design improvements. And what we also found is that that engineers, as they use the tool, they wouldn't make those same mistakes, as often, right? They'd learn and they'd say, okay, I know now I have to have my hole this far apart, or I've got to do a, chamfer on the top edge instead of a radius. And those are just simple examples, but it could be for casting, it could be for injection molding, all the various checks and analyses that DFMPro provides. They leverage that, they get an understanding, and then what happened is they would have a cube mate, and that person maybe didn't know about DFMPro, or they were just beginning to use it. They could get guidance because now you had so many people that were using the tool, and they could expand that, the tribal knowledge in a positive way instead of tribal knowledge sometimes in a negative way that we sometimes experience.
All right. And I see one more question here. Can you describe how DFMPro helped identify issues within a design?
So the detailed analysis that DFMPro provides allowed the pinpointing of areas that engineering and design or designers needed to focus on. And it is that assistance the tool provides for each finding, further expanded their knowledge with those specific checks. And what we found is once you have that, once your design is improved, right, then anyone using that design later on, using the tool, they won't have the same mistakes. You have a good foundation that they're working from. And we had, you reduce, change notices downstream. But the biggest issue is you have manufacturing that's happier, right, with engineers. We're famous for throwing stuff over the wall, and so manufacturing is not always happy with us, but they seem to be much happier when you go through that early process. But also you actually produce better products that are more manufacturable and go together better. So if you're using just dimensional tolerancing, or if you're using like GD&T, which is what I prefer. You can improve your the amount of product that all works together, and you get a higher throughput.
Okay. All right. Well, it looks like those were the questions that we had. So I would like to, on that note, thank you all for joining us. We hope that this was valuable for you. And a special thanks to Charlie and William for their time and expert insights. Also, thank you to our sponsor, HCL, for their support. So if you missed any part of this presentation, it will be archived shortly, so you can view it again or refer someone else to it. Have a great afternoon.